Okay, this is my first release candidate for my first Rust embedded project. This is a LED smart controller. I've got a strip of 20 WS2812 LEDs here. And I've got a 5-volt power supply. It's just a 40-watt power supply. And this is just my programmer debugger. So this is a XIAO M0 from Arduino. It's a ARM6 chip. So I've got 5 volts coming in, and it's 3.3 volts linear low dropout voltage regulator. And this is tied to the interrupt on the Arduino. And so basically all this does is it cycles through a sized array of LED solid colors at the moment. So future versions will do cooler stuff like animations, breathing animations, things like that. And this will actually be able to change not just between like colors, but modes. You can go from changing solid color modes to changing animation modes. And then, so basically, this is a 3.3 volt logic chip, but it's powered at 5 volts. So I've got 5 volt power and a 3.3 volt signal. So this is actually operating over SPI. Not quite SPI, it's actually just using the SPI bus to do pulse width modulation at a particular time. So these are timing sensitive chips. So your time high and your time low determines what colors and signals and stuff it sends. So since this is a 5 volt LED, I need to level shift. So basically this is you can do 4, it'll level shift bidirectional up to 4 signals. It's just I believe it's a BSS 138 transistor with 10K resistors on both sides, and then 4 of those. So obviously I'm only using 1 line. So this shifts the logic from 3 volts up to 5. And then I've just got a capacitor on the line there to kind of protect that first LED, and a resistor to just kind of smooth some things out. So really right now, just as a proof of concept, I've only got 3 colors programmed in, but it's trivial to add, however many more I want. And just pressing this button once changes. So I've got red, green, and blue cycling. So that's it. Everything is tied to a switch here, so I can turn off everything. And I've got the schematic for this linked up on my GitHub account. So I will link to this particular state. I've got a tag for it in the video. I'll link to my GitHub repo for that. And in the GitHub repo, there's an electrical schematic and everything, so you can take a closer look. Thanks for watching. Bye.